up to 78 millitesla right now. And we are working basically with a GMR effect as well as with a TMR effect.
Okay.
For example, for traction inverters, you typically have to reach an accuracy of 2% overall errors. Okay. And in case of a battery management system, you have to be more precise. We are focusing on TMR, can reach up to less than 1% error. Nice to meet you.
Nice to meet you too.
Yeah, my name is Christoph. Hello.
Cool. So we're at the second demo on the Alps Alpine booth. So what's going on here? I can see there's a hairdryer.
Right. The hairdryer is used as an example, for example, measuring the current without a core. Mm-hmm. So we can measure directly the current at the wire, and we are measuring the magnetic field using an MR effect.
Oh, okay, cool.
So this you cannot see probably, but this is a small chip, TSSOP8 package size, and it's directly connected or directly measuring the measuring field without any flux concentrator. And this is a unique point for us.
So this is all external measurement?
Right.
Cool.
We are measuring without a flux concentrator like whole elements are doing typically. And we are using that here as a demo just for showing that it's working. Mm-hmm. Of course, this is not the typical application we target. Our target is mainly traction inverter and battery management system.
Okay.
This is the main point. This is basically shown on the left side here. So.
Okay, cool.
Yeah.
Can we see it?
Sure.
In action?
You can see the demo. Actually,
yeah.
This is heating up, of course.
Yeah.
In the first, you can see the signal is changing. So on the lower side, you can see the current which measured, and the power is on the medium side. And if I'm going up to the second, so heating up the hairdryer. So the current measurement, you can see the chart is changing, amplitude is changing, and yeah, the power is transferred. No? It's about 360 watt now, which is hairdryer is. So this is how we show the direct measurement at the cable.
Oh, excellent.
Yeah.
So if a design engineer was looking to evaluate this device, do you have an evaluation board?
Sure, we have. You can see that exactly here. So these are examples of the evaluation boards we typically give to customers. So it can be connected directly with the cable, and this is a small tool also to display. For example, if you see the magnetic field here.
Oh yes,
it's
nice.
Changing. So this is one device, and maybe the second phase and the third phase. And the measurement is done in this direction, always in only one direction.
Okay.
So the placement is important in the system. So if you measure at the bus bar or for a traction inverter, yeah.
Cool, excellent. Just in terms of numbers, what kind of sensitivity do you get, and what's the kind of upper range on the magnetic field?
Yeah, we have different versions, as you said. This is a platform up to 78 millitesla right now. We have a sensitivity.
Okay. That's good.
Yeah. And we are working basically with a GMR effect as well as with a TMR effect.
Okay.
So this is a GMR effect demo, and for example, for traction inverters, you typically have to reach an accuracy of 2% overall errors. Okay. And in case of a battery management system, you have to be more precise for the measurement. That's why we are focusing on TMR there and can reach up to less than 1% error.
Good.
Yeah. This is our target. But this example is just a GMR demo or GMR chips.
Excellent. Well, thank you for talking to us. At the end of these interviews, especially since it's the second day of the show, quite like to ask how have you found, I guess you are in the PCIM section, but PCIM and sensor and test this year, how have you found it?
Actually great, I must say. So it's the second time we are here. So after the lockdown periods, it's the first time, and we can see in this hall many key players. So we can see customers, we can see directly connected suppliers, which are, it's really excellent show for us to especially demonstrate on EV cars applications.
Yes, yeah, it's quite popular. Yeah. So that was our second part of the interview with Alps Alpine, still about their magnetic sensing technology, this time obviously using quite a cool application, remote current sensing. Learn more on the ipXchange website, where you can also apply to evaluate the technology. Take care. You know I love magnets.